Hey everyone. Today we will learn how to decompose this matrix A into a lower triangular matrix and a upper triangular matrix, right? So we will denote the lower triangular matrix as L and upper as U. So what does lower triangular matrix means? This means that uh, like suppose we made this matrix, right? Like 1, 2, 3, 1, 2, 3, and 1, 2, 3, 3 by 3 matrix. So lower triangular matrix means the upper part, like this one, and this part would be 0, right? Like we don't care about this part. We do not care about this one, but like this part should be 0. Similarly, for upper triangular matrix, like U, let's say this is diagonal, and this part, like the lower part of the matrix, should be 0 for the U, okay? So let's just repeat what I just said. For upper triangular matrix, for lower triangular matrix, my bad. For lower triangular matrix, the upper part, the upper portion of the matrix should be 0. And for the upper triangular matrix, the lower portion of the matrix should be 0, okay? Now, we will decompose this matrix A into lower triangular matrix and upper triangular matrix. Let's start. I will just erase this because I don't need this, and I will just erase this part. Okay. So let's find upper triangular matrix. Like we have to make this matrix A into upper triangular matrix. Let's start. 4, 8, -8, 4, 4, 2, 5, and -3. So let's change it. Like we want, for this matrix, we want this part to be 0, right? Like this part to be 0. Okay. So let's start with the second column. So how can this be 0? Like how can we change 8 to 0? So you divide like -2 times R1 plus R2, right? So this becomes like -2 times the first row, 4, -2 times 4, plus 8, R2, right? My bad. R2 plus 8 equals to -8 plus 8 equals to 0. So we made this 0. Similarly, for 4, it's gonna be -2 -2 times -1 plus -4 equals to 2 minus 4 equals to -2, right? So we will do this. Equals to 4, -1, 2, 0, -2, and it's gonna be -4 plus 5 equals to 1, right? The last one is gonna be the same, -8, 4, -3. Okay, now it's time to change this to 0. Also, one crucial thing, so if you are changing like this portion to 0, you cannot use this row, right? Like you cannot pivot. You cannot use this row. You can just use this upper row, right? Just remember that. Now, for the third row, my bad, third column, like you cannot use this column. You can use this column. Now, for the third column, we're gonna change this to 0, How are we going to do that? It's going to be 2R1 plus R3. Also, since these two are going to be like above this row, we can use both of these rows. Just make sure these two are 0, okay? We just need these two 0. It's going to be equals to 4, -1, 2, 0, -2, 1. 2 times 4 equals to 8, minus 8 is 0. 2 times -1 is -2, plus 4 equals to 2. 2 times 2 is 4, minus 3 is 1, right? Now, we need to change this to 0. Since, like, if we use this row, there is a possibility that this will not be 0 anymore, right? So, since this first stuff of the second column is 0, this is not gonna change this one, like this value, 0 value. So let's use the second column. So how do you make it 0? It's gonna be R2, 1 R2 plus R3, right? 1 R2 plus R3 equals to 4, -1, 2, 0, -2, 1. 0 times 0 is 0. 0 times 1 is 0, plus 0 is 0. 0. And 1 times -2 is -2, plus 2 is going to be 0. So 1 plus 1 is going to be 2. Okay. That makes sense? Okay. So this is our upper triangular matrix. This is our upper triangular matrix, U. Okay. So how do we use the upper triangular matrix to find the lower one? L equals to what, right? So let's just do this. We know that for lower triangular matrix, it's going to be 1, 1, 1, and 0, 0, 0, right? So let's look back, right? How did we convert this matrix A to U, upper triangular matrix? So let's see. We use, like, to convert this 8, we use -2, right? To convert this 8, we use -8. -2, my bad. Yeah. To convert the 8 to 0, we used -2, R1. So it's gonna be -2 to +2, okay? Similarly, right, to convert this -8 to 0, convert this to 0, we use 2, right? That's 2. So it's gonna be -2. Again, to convert 2 to 0, we used 1. So 2 to 0, we used 1. So it's going to be -1, right? Clear? So this is our upper triangular matrix, and this is our lower triangular matrix. Let's change the color so that it's easier to recognize. Color, red. I want it as red. We will now copy this because I don't want to write it again. Copy. And paste. Voila. Okay. So why do we change the form of, like, why do we decompose a matrix to two form, like upper triangular matrix and lower triangular matrix? Why do we do that? First application, it's easier to find the determinant. Let's find the determinant. Determinant of A, right? How do we find the determinant? So that A, I prefer this way. I know that some people write this, but I prefer that A equals to that U times that L, right? It's pretty easy. So determinant of U is gonna be the multiplication of this, right? Simple, right? So determination of U is gonna be 4 times -2 times 2. Similarly, let's determinant of U. Similarly, determinant of L is gonna be the multiplication of this one. 1, 1, 1, 1, 1, 1. Okay. So it's gonna be 1 times 1 times 1. Simple, right? After we do the calculation, equals to 4 times -2 is -8 times 2 is -16, right? This is gonna be the determination of A. Now, let's find the inverse of matrix A. Inverse of A equals to what? We know, right, to find the inverse, like let's say this is matrix A, times its inverse is gonna be an identity matrix. That is, identity matrix equals to 1, 0, 0, 0, 1, 0, 0, 0, 1. So we know that like the product of matrix A and matrix A inverse is always going to be a identity matrix, right? So let's divide this identity matrix into 3 parts, right? 3 columns. So it's going to be 1, 0, 0, 0, 1, 0, 0, 0, 1, right? So doesn't this mean that, let's go with A times, let's also divide the column of A inverse, like inverse of A. Let's divide it by A -1, A -2, A -3. Similarly, A 1, 2, I think, yeah. A 2, 2, A 2, 3, A 1, 3, A 2, 3, and A 3, 3. Right? Inverse, 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 inverse. It's just right. I will just take it a bit far, right? Equals to. So does this not mean A times A11 inverse, A21 inverse, and A31 inverse equals to 1, 0, 0, right? So does this not mean that first, the multiplication of first column, like the multiplication of first column of A is gonna be equal to the first column of the identity matrix, right? This is the concept that we are gonna use to find the A inverse. Okay, let's start. I will just copy this one, just for my own convenience. Copy, come on. Copy, okay. Paste. So, from this principle, right? From this principle, we're gonna use, I will introduce you to a formula. So lower triangular matrix L times Y is equal to B, that is identity matrix, right? B is the identity matrix. And similarly, upper triangular matrix times X, that is this is gonna be the, like X is gonna be the column of the inverse of the matrix, right? You will understand after I solve this question. Equals to Y, which we are gonna find from this one. Okay, let's start. So we know that L, we have decomposed. Alexa, nothing. Okay, that was just my Alexa, my bad. Okay, let's see. What was my UNL? We'll just copy this, copy, and paste here. This was our this was our decomposition to UNL. So for the first column, right, we're gonna do it for the first column. First column, we're gonna find the first column, right? So it's gonna be L times Y, right? So L is 1, 2, -2, 0, 1, -1, 0, 0, 1, right? This is L. This is L, this, right? Times, we don't know what Y is, right? So we have to find Y. Y1, Y2, and Y3 equals to, B is the identity matrix. This B is the identity matrix. Since we are finding the first column, right? We're finding the first column. So 1, 0, 0, 0, 1, 0, 0, 0, 1. This is what the identity matrix is. So we are finding the first column. So what is the first column of the identity matrix? This is the first column, right? Is equal to 1, 0, 0. All good? Okay. I will remove this. Okay. So looking at this, Y1, the first column, look at this. So 1, Y1 plus 0, Y2 plus 0, Y3 equals to 1, right? So it's gonna be Y1 equals to 1. So remember this. Similarly, 2Y1, the second column, we are looking at the second column here. 2Y1 plus 1Y2 plus 0Y3 is gonna be 0. So we do know that Y1 equals to 1, right? So 2 times 1 plus Y2 equals to 0. Y2 is gonna be -2, right? -2. Similarly, let's find Y3. Y3, third row. My bad, third row. I always get confused with one column. Sorry, guys. Third row is gonna be -2 Y1 and -2 Y1, -1 Y1, -2 Y1 plus -1 Y2, plus y3 equals to 0. So 2 times y1 is 1 minus 1 times y2 is negative 2 plus y3 equals to 0. Solving, y3 equals to equals to 0, right? So from above, from above, y1, y2, y3 is gonna be 1, negative 2, and 0, right? 1, negative 2, 0. Now, we'll be using u x equals to y. X is the inverse, right? X is the inverse. U is 4, 0, 0, negative 1, negative 2, 0, 2, 1, 2. X1, x2, x3 equals to y is gonna be 1, negative 2, 0, right? Okay, let's start with the third row because it's easier. We have all the values. So it's gonna be 2x3 equals to 0. So x3 equals to 0. This is the third. Moving on. 0, negative 2x2 plus x3 equals to negative 2. So negative 2x2 plus 0 equals to negative 2. x2 is going to be 1. Finally, finally, 4x1 minus 2 minus 1 x2 plus 2x3 equals to 1. So 4x1 minus x2 plus 0 equals to 1. So we know that x2 equals to 1. So 4x1 minus 1 equals to 1. x1 is going to be 1 by 2. Right? Looks good. So A inverse equals to something and hold this after all this process, we have found the first column, right? So x1 is going to be half, 1 by 2. x1 equals to 1 by 2. x2 is 1. And finally x3 is 0. So after all this, we have found the first column. And we have to do the same process for the second column, right? So let's go, I guess. I mean, it is tedious, but if if they ask you to like find A inverse through like using LU decomposition, then you have to go through all this hassle. But yeah, I know it is tedious, super tedious, and I do not recommend using this method unless it's specified in examination. But usually they will just like ask you to find first column of A inverse, or like first column of A inverse, or second column of A inverse, or like third column of A inverse. They will not ask you to find whole A inverse. I mean, if a professor is merciless, then he will ask you to find all of this. But yeah, this is how you find the first column, right? So let's recap. Like, I'm not gonna be doing all of this, but because like it is super tedious and the video is gonna be super long. So I just wanted to show you guys how to actually like, give you an idea how to find the A inverse. Like, this is how you do it. Let's recap. First we talked about LU decomposition, like how you can like decomposition, how you can like decompose this matrix A to upper triangular matrix and lower triangular matrix. After that, I taught you how to do the determinant, how to find the determinant of A, like how to find the determinant of A using upper triangular matrix and lower triangular matrix, right? It's super easy. Finally, I told you the concept of finding the A inverse, right? This one. And you should be good. Like, you should be good. That is all for the video.